Okie dokie. So I'm going to switch to black. Okay, so we've looked at several different strategies to solve a quadratic equation, right? We started with like factoring, okay, using the AC method, right? Or sometimes you do GCF, right, as well. We want to make sure if you use the factoring method that you have your function equal to 0 first, okay? Then you factor out a GCF if there is one, okay? And if there's no GCF or if you factor a GCF, then maybe you need to use the AC method too. Once you factor it, okay, then you want to set each part of the product there, these two factors equal to 0, and then you solve them. Okay? We've also used square roots, right? And I didn't have an example in the warm-up like that. Well, I guess we ended up using square roots here. Okay. So we used square roots before. There are sometimes problems where we can just use square roots. We don't need to complete the square. But then there are problems that we need to complete the square and then use square roots to solve. Okay. The last method we're going to show you here is using the quadratic formula. And this method will work for any quadratic you come across. Okay? So what's the deal then? Why don't we just learn that first? Well, it's because the quadratic formula, can be a little bit of a pain in the butt. Okay? So before we talk about the quadratic formula, just to highlight something here. Your quadratic equation must be in standard form. So in other words, we must have it in ax squared plus bx plus c equals 0, okay, form there. This is standard form. Okay? And Chris, I took away your review because I messed up the copies and there were like missing questions. So I recycled those and I'll get you a new one tomorrow. Okay? Everyone.
Recorded.
Yeah. Mm-hmm. Yeah. So, standard form, boom, right there. And so what's the quadratic formula? All right. This is a formula that you will not need to memorize. I will give you a formula sheet, and this formula sheet will contain the quadratic formula on it. Okay, so you will not need to memorize any of this formula at all. If you want to remember it, there's like a million songs and raps on YouTube. People trying to become like YouTube famous or just like want to, just help students out and stuff like that, and they make all these songs. You can actually sing this to the song Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Do you remember that?
Yeah, so it works. All right, if you have to have a way to remember it, if you want to try and remember it, that's one way you can do it. Okay, if you know the song Pop Goes the Weasel. Okay. So this is what we'll be using. So you can see the A, the B, and the C, right? These A's, B's, and C's you see in here, they all come from our quadratic equation here. We use the lead coefficient, the A for A's. You have the A there and the A there. We use the B right there. We put that in for the B there and the B there. And we put the C in for C's only used once. It's right there. Okay? So, you'll notice like some of the parts here, this negative b over 2a, for example, remember we used that to find the vertex of our quadratics. Or we can use the vertex. You can use it to find the vertex. Of course, we just did it with transformations and stuff, I think. But anyway, you can use it to find the vertex there too. And then inside the square root is something also very special. So I'll circle that here in red. This little part of the quadratic formula, okay, is known as the discriminant. Okay? Mr. Witt, I thought discrimination was bad. Okay, well, some discrimination is bad, okay? But not all discrimination is bad, all right? You discriminate between foods that you like and foods that you don't like, right? So there are some things you don't want to eat, right? Because you don't think that they are tasty, right? That is being discriminating too, okay? And it's not necessarily a bad thing, okay? So what does the discriminant help us do? Okay, so the discriminant, that little part of the quadratic formula, it's used to determine the number and type of solutions to a quadratic equation. Okay? Because that quadratic formula can be pretty complex, right? There's a lot of little pieces to it here, a lot of little calculations. And this is why we save it for last. Because yes, it solves all the equations that we've done up to this point. Any equation can be solved using quadratic formula, or any quadratic equation can. But it's just, look at it, it's really complex. There's a lot going on there, okay? And so it's kind of like, it's like a payoff, right? Or it's like a trade-off, I should say. On the one hand, it will solve anything. On the other hand, it's a formula, and like it's pretty complex as a formula. Okay, you might find factoring to be easier, right? You might find completing the square to be easier. I don't know about that, but anyway, square roots might be easier for you, something like that. Okay, so you wouldn't want to use this for every single problem you do, but you could. You could if you really want to. If you want to just have like one way that will always work, this is the way. The discriminant is then this part of the quadratic formula, like I said there, and it's used from a number of solutions. And so how? Well,
should the quadratic formula work for everything?
Quadratic formula works for any quadratic equation. In standard form. Make sure it's got to be in standard form. For example, in the warm-up here, this one was not in standard form. I need to subtract the x over, and then from right here, a would be 1, b would be -4, and then c would be 0 since there's no c. And you just solve. Okay. If your discriminant is greater than 0, that means you have 2 real solutions. So the discriminant will not tell you what the solutions are, it will just tell you how many solutions there are, which can be helpful information. It's a quicker calculation, but it tells you less information. Right, again, a trade-off. Okay. If b squared minus 4ac is equal to 0, then there is one real solution. And then finally, if b squared minus 4ac, well, what's our third option going to be?
Is less than 0.
Is less than
no
0.
solution.
Then there are no real solutions. Or in fact, I should say there's 2 non-real solutions. So no real solutions, but there will be 2 non-real solutions. Every quadratic equation should have at least one solution. There should never be a quadratic equation that doesn't have a solution. The solutions might be imaginary, or they might not be real. I mean, they might not be real, but they're not. There's no solution quadratic equation. Okay. So let's see this in practice. So we'll start with just using the discriminant. Then we will graduate to our big boy and big girl, formula here, okay? But we'll start with just using the discriminant for right now. So determine the number / type of solutions. So let's try number 1. We'll say x squared plus 8x plus 17 equals 0. Okay. So to use our discriminant here, we need to know what b, what a, and what c are from our quadratic. But first, is our quadratic equation in standard form here? Yes or no? Is this in standard form? It is, right? We have our x squared, our bx, and our ax squared, bx, and c, and there's no number over here. So what number is a in this problem?
It's 1.
Okay, right. The a here, there's no number written, so we can say it's 1, right? Okay. What's our b? 8. What's our c? 17. You got it. Okay, so then we'll use our discriminant here. B squared minus 4ac. Okay, so again, we're not solving this. We're not finding the actual solutions. I mean, you could answer this by using quadratic formula if you wanted to, but we're just going to use a discriminant here. Okay, it's quicker and easier. So we'll plug in 8 for the B, we'll plug in 1 for the A, we'll plug in 17 for the C. Okay. So 8 squared is 64. Yeah, and then 4 times 17, let's see, 34, 68. 1 times 4 times 17 is 68. And then 64 minus 68, what's that equal?
It's going to be 4.
Negative 4. Okay, so there's our discriminant. Negative 4. Let's go up here. Which one of these three options here does our discriminant fall into? Is it 2 real solutions? Is it 1 real solution? Is it going to be 2 non-real solutions?
2 non-real solutions.
2 non-real. Okay, right. Our discriminant here is negative, which is less than 0. So we're going to have 2 non-real solutions. Okay, so 2 non-real solutions. Okay, it's not very satisfactory though, right? Because it's like, well, what are the solutions? Well, the discriminant doesn't tell us that. It just tells us how many there are. Okay, all right, we'll do 2 more here, and I'll have you guys try one on your own. X squared minus 4x plus 4 equals 0. All right, so let's go to Christian. In this, I know you just got it back, Christian, but I think you can really answer this question, okay? All right, what's the A, B, and C in this quadratic equation? Well, first of all, let me ask you this question. Is it in standard form? Do we have it in standard form like this, ax squared plus bx plus c? Is that what we have here? Yes. So what's our A? So, yeah, there's no number in front of the x squared, but what number could I put in front? A 1. So actually the A is going to be just a 1. Make sense? What's our B, Christian?
4x, negative 4x.
So yeah, the negative 4, we just need the numbers, okay, just the coefficients there. And then how about C?
And then just 4.
There you go, very good. Okay, A, B, C. Great job. So now we'll use our discriminant, b squared minus 4ac. Okay, we'll put the negative 4 in for the B, 1 in for the A, 4 in for the C. Okay. And we will simplify. So let's see, that gives us 16, right? Minus 4 times 1 times 4 is another 16. So 16 minus 16 is 0. Okay. So let's go back up here, right? If our discriminant is 0, how many solutions do we have? And what kind of solutions? Let's go to Jacob T. What do you say, Jacob T? 1 real solution. You got it. Exactly right. And I'll explain more about how this is so, right? You guys are just kind of like taking it for granted that I'm telling you the truth here, right? I could be completely lying to you because, you didn't really see me prove this or anything like that. I'll show you later how we can kind of like justify this, so that way you'll at least be convinced, okay, that it's true. All right, one more together, and then I'll have you guys try one on your own. 50x equals negative x squared. Oh man, Mr. Wade, you're changing it up on us. Changing it up on us. Michael G.
Yo.
Is this equation in standard form?
No.
No. What would I need to do here to make it in standard form?
Don't you need to arrange them?
Okay, so what should I move? What would you like me to move?
The x.
When you say x, do you mean the 50x or do you mean like the negative x squared? They both have an x, so I'm not sure which one you mean.
The negative x squared.
Okay, so how would I move that? What would I do to both sides?
Would you use add?
Yeah, add an x squared to both sides. This is one way to do it. It also would have been okay, Michael, for you to subtract the 50x to both sides too. But I like yours better. This is what I would have done because I don't like having a negative lead coefficient like that. So we'll have x squared plus the 50x, no c value there, and equals, what's going to be left over here, Michael, when we add the x squared to the negative x squared?
Just an x, right?
If you have a negative x squared and you add an x squared, they are exact opposites. When you add exact opposites, what do you get? Not just not an x, no. You want some help? All right, let's go to Shane. Shane, when I add a negative x squared and a positive x squared, what do we get? Nothing, which in other words is 0. Okay, is that what you said?
No,
Okay. Okay, gotcha. So now we're here. We're on standard form. Okay, so let's go to man, someone's here. Nick, what is our A in this equation?
X squared.
Okay, so what's the number in front of it?
Oh, 1.
A 1, yeah. So we're only going to use the numbers there for our A. What's our B here, Nick?
50.
50. What's our C?
Yeah, 0.
Yeah, there's nothing there, right? So we'll just squeeze it in there and put a 0. That's right, put a C. Okay, so plug it into your discriminant, which is B squared minus 4AC. Okay, so it'll be 50 squared, yikes, 50, minus 4 times 1 times 0. Okay, now you might balk at the idea of trying to do 50 times 50 in your head, but it's not that bad, right? What's 5 times 5?
25.
25, but then each one had another 0, so it'll be
250.
close, 2,500. We have to add 2 zeros because each 50 had a 0 there, so we had 2 zeros on there. But you're on the right idea there, Luke, exactly right. So 2,500. Okay. And then this isn't actually that bad. 4 times 1 times 0 is just what? 0. So you get 2,500. Okay, so let's go back up. Oh, I can't quite do it, but I zoom out. I can do it. Okay, go back up here. Okay, if our discriminant is 2,500, Garrison, how many solutions and what type do we have?
2 real solutions.
2 real, you got it. Great job, Garrison. 2 real solutions. Okay. And now I've given you one example of all 3, so you're not going to be able to just guess what this next one's going to be. You'll actually have to figure it out, right? I know math teachers sometimes do 2, and then give you the third one. Oh, I know the third one's going to be the last one that we haven't done yet, right? Well, now I've done all 3, so you have to figure out which one it's going to be. All right, so try negative 5x squared minus 2x minus 8 equals 0. I'll go easy on you in some sense.
Can you write the formula?
Yes. In fact, you know what I'm going to do instead? I'm going to give you guys your formula sheets so that way you can have practice pulling from that. Yeah, you feeling okay on this stuff so far, Allison?
Huh?
You understand it okay so far?
Yeah.
Okay, then yeah, go ahead. Okay, I'm going to pass out formula sheets so that way you can use those to refer to. Quadratic formula is right there. There's your quadratic formula right there. So Bobby is going to be right there, and the discriminant is the part underneath the square root. Okay? You don't even need to use the square root part, just the part underneath the square root. These are not for you to keep, okay, so please don't write over them, okay, but you can use these. These are formula sheets we'll use. Sorry, here. We can patch it up. Sure, give us like okay. Okay, you got it. We're going to actually use the quadratic formula in a second. And just you guys have some practice here with looking at the quadratic formula. Yeah, go ahead. Go ahead. Okay. I'll give you 30 more seconds here. Okay, let's go to John. John, first of all, is this in standard form?
Yeah.
Yes, it is. Okay. So John, what's our A? What's our B? What's our C?
A is -5.
Yes.
B is -2.
Okay.
And C is -8.
Very good. Okay, so we're going to then use our discriminant here, which again is the part underneath the square root in the quadratic formula. So it's b squared minus 4ac. Okay, we'll use John's numbers there. -2 squared minus 4 times -5 times the c of -8. Okay, excuse me. -2 squared is 4. Okay, let's see here. -5 times negative is 40, positive 40, but then 40 times 4 is, so it's going to be like minus 160. So we get negative 156. Is that you guys got for your discriminant? Negative 156. Yes? Okay. You can also type the whole mess in your calculator if you want to. So like, for example here, just to give you an idea. Okay. If you just type this whole mess, so parentheses, -2, parentheses, squared, minus 4, parentheses, -5, parentheses, and then parentheses, -8, parentheses, okay?
And then could you also do the entire quadratic formula?
Potentially, but I would steer you clear of that because with the quadratic formula, you might need to simplify square roots, and your calculator won't simplify square roots, so it'll just give you a decimal. So, but yeah, you can use your calculator. I'll show you how you can use your calculator to help you with it at least some. Yeah. But anyway, there's our discriminants. All right, so Lindsay, what does that mean then? If our discriminant is -156, that means what kind of solutions and how many do we have? 2 non-real. Exactly right, Lindsay. Good job. Okay, just like so. Question? Yeah, sure. We're gonna start the quadratic formula, so be quick, okay? So you don't want to miss out.
Can I go to the bathroom real quick then so I can get back?
Sure. Okay. All right, so now we're going to actually solve an equation. Okay. So this is different. We're not finding the number of solutions. We are finding the actual solutions. Okay. So let's start with an example here. We'll do x squared plus 10x minus 7 equals 0. Let me pause first before we jump into the quadratic formula and all that stuff we would normally do. And let me just, again, let's review some of the other things. Because sometimes when you're in a math class, right, you might just be given a problem like this and just asked to solve it. And the directions may not specify what strategy to use, which means you have choice, okay? And sometimes choice can paralyze us because we have too many choices to pick from, okay? Right? So, if you go to the grocery store or something like that, there's 50 different pasta sauces you could pick, you know? These ones have mushrooms, these ones have onions, these ones have mushrooms and onions, these ones don't have any mushrooms or onions, but they got sausage, you know? So it's crazy. Same thing here with the math problem, right? You have so many different options here, all right, that we can pick from to solve quadratic formula. We really know 4 methods. So let's kind of go through this here. I mean, for example, could we factor this? So look at your A and your C. So your A is 1 times -7. So 1 times -7 is -7. Can you think of 2 numbers that multiply to make -7 and add to make 10? -5 and -2. So they add to -7 and they would multiply to positive 10. But remember, the 2 numbers need to multiply to -7 and add to make 10.
7.
So 7 would be -7 and +1 or -1 and +7. Either way, they wouldn't add to make 10. So in other words, does this factor? No. Okay? So right away we can see factoring won't help. Okay? Could we use square roots here? Well, I have x and x squared. So if I were to move that 10x over and I were to square root both sides, I'd have x's over here, right? So square roots would not help here either. Could we complete the square here?
Yes.
Yes, we could, right? We could move that 7 over. We could, then, it would be 5, right? X plus 5, x plus 5. So you could use completely the square root and then use square roots. That would be an option, okay? But we're going to use quadratic formula. So in other words, factoring doesn't work. Square roots didn't quite work unless you complete the square first, and then you can use square roots. Okay? But we're going to use quadratic formula just because we want to. That's our new thing we're learning today. All right. So again, I'm going to write the formula up here, just so we have it to reference. But you guys have it in front of you too. So if anyone's curious where this formula comes from, I'll be happy to show you that too. It actually uses skills we already know. Okay, it's just I don't want to spend the time to go through it and stuff like that. So if you're curious, I'll be happy to show you at some point. Okay, later today if you want. Anyway, let's go to someone. Let's go to JK. So JK, what is our A value here for our quadratic? 1 again. Very good. Okay, what's our B? 10. And our C? You got it. Very good. So we're going to now plug each one of these numbers into the appropriate place in our quadratic formula. So we're going to have x equals negative parentheses 10. So the b is supposed to be negative, so I'm going to get negative parentheses 10 like that, right? Plus or minus the square root of 10 squared minus 4 times a, which is 1, bless you, times c, which is negative 7, all over 2 times a, which is 1. Okay. So there's our setup. Let's simplify, right? So what I would encourage you to do is to simplify this discriminant first. Take what's underneath the square root there and just type it into your calculator. So I'm literally just going to take that, 10 squared. Please use parentheses just like you see there. It will make your life a lot easier. Okay? See how I'm typing it in? 10 squared minus 4 times 1 times negative 7, right? I hit enter. And 128 is what goes underneath the square root. So this becomes a negative 10 plus or minus the square root of 128 all over, and then 2 times 1 is just 2. Okay? And so technically, those are our two solutions. X equals negative 10 plus the square root of 128. X equals negative 10 minus the square root of 128. Well, again, both divided by 2 there. But we should be able to simplify this too. So let me show you how we're going to simplify. Okay? So any questions up to this point? I'll stop there. Pause there. Any questions up to this point? And where any of this came from? So then from here, okay, when you have a fraction, adding or subtracting in the numerator, you can break it up over the denominator. So in other words, this is equal to negative 10 over 2 plus or minus the square root of 128 over 2. Like so. Okay. And I break it up because what's negative 10 divided by 2?
Negative 5.
Yeah, negative 5. We can just make that negative 5. And now we need to simplify this. Instead of dividing by 2, I'm going to put a 1/2 in front. And then we have to think of perfect squares that divide 128. So can you guys think of any perfect, or anyone want to guess a perfect square that divides 128? You don't have to be right. Just what's a perfect square that might divide 128?
8.
Okay, 8's not a perfect square.
You said it doesn't have to be right.
Right, but what I mean is, so try and pick perfect square. So I mean like 4, 9, 16, 25, 36, 49, 64, 81, stuff like that. Let's try 4, right? Okay, what are you going to say, Hannah? 4? Yeah, 4. Yeah, let's try 4. Okay, so 128 does divide by 4. I'll show you here, right? 128 divided by 4 gives us 32. So we can take that root 128 and make it root 4 times root 32. Okay. In fact, you know what? Here, I'm going to do this instead. Let me just do this over here to the side. So the root 128 is equal to root 4 times root 32. And we did that because what is the square root of 4? 2. Okay. Can I divide 32 by any perfect squares? Divided by 2?
So it's not perfect square.
16 and 2, though. Yeah, so you're right, it's not value, but 16 is. So let's make it 16 and 2. Right? What's the square root of 16? 4. So we're going to have 2 times 4 times the square root of 2, which in other words we have 8 times the square root of 2. Okay? So let me just do this. So that root 128 becomes 1/2 times the 8 root 2. So again, maybe I should do it this way. Shoot, I'm sorry. I think I'm making this more confusing than I need to. Negative 10 divided by 2 is negative 5. Okay? The root 128 we simplify to be 8 square root of 2 over 2. Just like that.
Like the root?
I'm going to move your jacket there for there too, please. So that way she can get in there. Thank you. All right. So there are our 2 solutions. Except we can do one more simplification here, right? What is 8 divided by 2? 4. So we get negative 5 plus or minus 4 times the square root of 2. Okay? So there are our 2 solutions. Negative 5 plus 4 root 2, negative 5 minus 4 root 2. Okay? X equals those 2 things. So the actual formula, not that bad. The simplification is where it can be a beast. Okay? A bit of a beast. Questions on any of that? That's about as bad as it gets, right there. Sometimes you'll have the square root of a negative, though, which means you'll have an imaginary number, too, right? So we want to be careful with that. In fact, maybe I'll do an imaginary one here. Yeah, let's do an imaginary one. Okay? I'll do the imaginary, or the non-real, the non-real one from on the other side. So one more example here, and I'll let you guys start on your assignment, okay? All right. So first of all, Matthew, is this in standard form? Yeah. Okay. What is our A, Matthew?
-1.
Not 1. Yeah, there you go. A is 1, right? Okay. What's our B, Matthew? 8. What's our C? 17. Okay. Very good. So, quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So I'm just writing it out for you. You don't need to write that out. You have it on your formula sheet. I'm just writing it out for us to refer to. So for our problem here, we'll have x equals negative parentheses 8 plus or minus the square root of 8 squared minus 4 times a times c all over 2 times a. Okay. There's our setup. And now we simplify. Again, I would encourage you to do your discriminant first. So parentheses 8 squared minus 4, parentheses 1, parentheses 17. Okay, there's my discriminant right there. Negative 4 is what you get. So this becomes negative 8 plus or minus the square root of negative 4 over 2. Okay. Let's go ahead and simplify that square root of negative 4. When I do the square root of a negative, right, you want to break off the negative 1 there so we can have a positive 4 to deal with here. What is the square root of negative 1 equal to? I. Very good. What's the square root of 4?
It's 2.
It's 2. Yeah, I heard you. It's 2. Very good. So then this becomes negative 8 plus or minus 2i over 2. And then we'll just break up our fraction. Negative 8 over 2 plus or minus 2i over 2. Okay? Negative 8 over 2 plus or minus 2i over 2, right? So both of these get divided by that 2. What's negative 8 divided by 2?
Negative 4.
Negative 4. What's 2i divided by 2?
1.
It'll be 1i, right? So we have the I. So you can just put I if you want to. If you want to put 1i, that's fine. Or just I is okay too. And there are two answers. Negative 4 plus I, negative 4 minus I. Okay, imaginary. Not real. Okay. Questions on any of that? Nay. All right. Well, then, let me get you guys started on your assignment here, okay? So your assignment will be out of the book. Starting on page, or actually I'm not sure the page, I'll have to look that up here. But it's in section 3.3.
Why do you have so much in the book?
Why do you have so much in the book? Because we paid a lot of money for this, so we try to get our money's worth. Just kidding. I don't know.
I was gonna say, like, why would you pay for it if you have it free online?
Well, we have it free online because we paid for the books. Like, we have access to the electronic books because we have it. Because we have the physical books. Wait a minute. Hang on. Oh, okay. Interesting.
Is it not in the book?
Sorry, I am looking at things here. So these... These, they want you to solve by completing the square. So just for some practice, I'll have you guys do those completing the square problems. If you want to jump ahead to the ones we just practiced, okay, 10 and 12.
So 3, 4, and 8 are only practice.
Yeah, it's like, so hang on, let me get this right up here. 10 through 14, use discriminant. And then the actual quadratic formula stuff will be 17 and 19. Okay, and the directions specify that, but I just wanted to highlight it,
So
okay?
you want 3, 4, and 8 only to be practice? Or and
Correct. Correct. Well, I mean, no, this is all part of your homework, Bobby. It's all part of your homework. Okay. And yeah, there's the page here. Just a sec, because I don't know that off the top of my head. I have a page number on what I'm looking at, but it's not the same pages as what you guys have, so I have to readjust. Okay, it starts on page 105. 105. Okay, and you can actually skip. Actually, you know what? You can skip number 1. Yeah, you don't have to do number 1. Forget about that. I said 105, right?
Yeah.
So there you go. All right, let's get started here, please. All right, I will come around and help. If you want to, feel free to do it out of order if you need to. So if you want to do the quadratic formula stuff first, do that first, okay? If you're feeling okay on completing the square and all that, okay? But let's get those books cracked open, okay? Or you can go to Schoology, or not Schoology, sorry, FCPS Bookmarks, okay?